Hello guys, today's lesson is an introduction about quadratic functions, general view, in part 1. Then in part 2 I will proceed for more details like roots and more graphical aspects. Let me introduce a quadratic function. A quadratic function has a general format of y is equal to ax squared plus bx plus c. We have three different coefficients here, c, b, and a. A must be always a non-zero coefficient. Otherwise, we will lose the quadratic term. B and C sometimes may be zero. It depends. The appearance of this function is sometimes like this, which is named concave up or opening up, or it could be like this, concave down or opening down. Also, this graph is named parabola. And each parabola must have a vertex. Sort of minimum, here is the vertex, and also could be a maximum, this vertex. If I draw a vertical line exactly passing through the vertex, it's named axis of symmetry or line of symmetry, axis of symmetry. And the reason for nomination is that if you fold the parabola on this axis, the left and right side will overlap. For example, if I select a point like A and then I draw a normal line to the axis of symmetry to the length of x, and then I continue to the same length, x, I will find the other point on the right side on the body of the parabola. Okay, let's learn about coefficients. To interpret the coefficients, I will start from c, the constant term. C indicates the y-intercept. Okay, when the parabola crosses the y-axis, it may cross it at a positive value, so c is positive. It may cross it exactly at the origin, so c will be 0, or may cross the vertical axis in negative values of y, so c must be negative. What about b? B is the slope at y-intercept. Anyway, the parabola must always pass the vertical axis, the y-axis, always. So if b is positive, we think that the parabola, when passed through the y-axis, must be increasing with positive slope, something like that, positive slope. If b is 0, the vertex of the parabola is exactly on the y-axis, something like this, because at the maximum or minimum point there is no slope. So slope is 0 at the crossing point with the y-axis. Or if b is negative, generally we think that the parabola may cross the y-axis when it's decreasing with negative slope. So the interpretation of b will be slope at y-intercept. What about a? A indicates the concavity. If a is positive, we know that the parabola must be opening up or concave up, or otherwise if it's negative, it's concave down or opening down. Okay, let's check our understanding. I show you some parabolas and let's guess the sign of each coefficient. About the a, in the three cases I see, the three are opening down. So I think a must be negative. What about b? About the b, I should check when the parabola crosses the vertical axis, if it is increasing or decreasing. Here I see positive slope, so b must be positive. Here I see positive slope, and here also I see positive slope. So b also must be positive for all. What about the c? C indicates the y-intercept. For the left one, here I have a positive y-intercept, so c must be positive. This one across the origin, so c must be 0. The last one indicates negative c because the y-intercept is negative, so c is negative. What about these three? The three are concave up or opening up, so I can say a is positive. What about b? Then let's check when the parabola crosses the vertical axis. Here is negative slope, here also negative slope, here also negative slope. So the three cases indicate negative b. What about c? Anyway, C indicates y-intercept, positive y-intercept, 0 y-intercept, and here I have negative y-intercept. C is negative. These three cases are still concave up, so I think A must be positive. About the B, as you see, the vertex of the parabola is exactly on the vertical axis, here and here. When the vertex is on vertical axis, there is no slope, so in the three cases, B must be 0. What about C? C is y-intercept. Here I have 0 value for C, here I have positive value for C, and here I have negative value for C because y-intercept is negative. Look at these three cases. About A, they are all concave down, opening down, so A must be negative. About the B, check the vertical axis when the parabola cross the y-axis. Here it's descending, here is also descending, here is also descending, so B must be negative. About the C, I have positive y-intercept here, so C is positive. I have 0 y-intercept, C is 0. I have negative y-intercept, so C is negative. These three cases are all concave up. A is positive. About the B, here I have positive slope, here I have positive slope increasing again, and here also I have positive slope. So I think B must be positive in the three cases. About the C, here I have positive y-intercept, here I have 0 y-intercept, so it's positive, it's 0, and the other one has negative y-intercept. The last three, they are all concave down, opening down, so A must be negative. About the B, as you see, all have the vertex on the vertical axis, so there is no slope when they cross the y-axis, so B must be 0, About the C, I think here C is 0, as there is no y-intercept. Here C is positive, so C is positive, and the last one has negative C. The last thing I should mention in this video is magnitude of A on concavity. Okay, let's draw y is equal to x squared. You remember the general format was y is equal to ax squared plus b plus px plus c. As you see, a is 1 here, b is 0, and c also is 0. When c is 0, there is no y-intercept. And when b is 0, the vertex is exactly on vertical axis. So the vertex must be at the origin. I draw something like this with concave up shape. Okay, what if I draw y is equal to 3x squared? It will have the same shape, but more concavity. More concavity, I mean, it's closer to vertical axis. As you see, it's descending faster and ascending faster relative to y is equal to x squared. So when a is going to be larger, the concavity is more and the trend of parabola is closer to the vertical axis. Look at this one. If I draw y is equal to negative x squared, I should draw something opening down like this. And if I draw y is equal to negative 3x squared, it will be the same shape but with more concavity again. As you see, it's ascending faster and descending faster, still closer to the vertical axis. Okay, thank you for watching this video. Proceed to part 2 to learn more details. In part 2, I will tell you more about the graphing and also some details about roots and more problem solutions. See you in the next video.